Welcome to my video on properties of determinants. What I'm going to look at today in this video is one particular property. If two rows or columns of a matrix A are equal, then the determinant is equal to 0. And I want to show this, not prove it, but I want to show it by doing a couple of examples. One where the first case where the rows, there's two identical rows, and the second case where there's two identical columns, and show that they both equal to 0. So let's try to find our first matrix here, A, and that should be a bold print. A is equal to 2, 2, 6, 3, 3, 1, and 4, 4, 1. Okay, we notice in this that the first two rows are identical, so it satisfies the criteria that they are equal. So let's see how that works out. So the determinant of matrix A is equal to, I'm going to write this out, 2, 2, 6, 3, 3, 1, 4, 4, 1. And then using the rule of Saros that we covered in a previous lecture, we take these first two columns and we move them over here. And so that's going to be 2, 3, 2, 3, 6, 1. So what we want to do now, next we want to cross multiply. And so we go along these diagonals. So it's going to be that diagonal, that one, and then we're going to subtract these diagonals. I want to get the lines drawn properly so I don't get messed up on that. So the determinant of A, taking the first diagonal, which is number 1 there, is going to be 2 times 3 times 1, plus the second one here, 3 times 4 times 6, 3 times 4 times 6, plus the third diagonal, 4 times 2 times 1, 4 times 2 times 1, minus, this one is 4, 3, 6, and then this one is going to be minus 2, 4, 1, and then minus this one, which is 3, 2, 1. 3, 2, 1. All right, let's do the multiplications here. 2 times 3 is 6, plus 3 times 4 is 12, times 6 is 72, plus 4 times 2 is... Now we're going to look at the minus diagonals. 4 times 3 times 6 is 12 times 6, that's 72, minus 4 times 8. 4 times 2 is 8, and then minus 3 times 2 times 1 is minus 6. Now we don't really need to do the math. We can just see that these terms cancel out. The minus 6 cancels with 6, 72 cancels minus 72, 8 cancels with minus 8. So what we're left is the determinant is equal to 0. So what we illustrated was this property of determinants, that if two, in this case, rows are equal, the determinant is equal to 0. Next, let's look at the case where we have two columns are equal in the determinant. So now we're looking at this case. So I'm going to use my matrix here. Is going to be a new matrix this time. 3, 3, 1, 3, 3, 1, 4, 6, 2. Now the determinant of A in this case, we're going to use the same method we used in the other one. 3, 3, 1, 3, 3, 1, 4, 6, 2. Move the first two rows to the right. 3, 3, 3, 3, 1, 1. Now we do our cross multiplication. So we're going to go down that diagonal, that diagonal, that diagonal. Then we're going to subtract off this diagonal, this one, and this one. So it's 1, 2, 3, 4, 5, 6. So let's do the math on that. So the determinant of A, looking down the first diagonal, that's 3, 3, 2, 3, 3, 2, plus 3, 6, 1, plus 4, 3, 1, 4, 3, 1, And now we subtract off this diagonal, so that's going to be 4, 3, 1, 4, 3, 1, minus the number 5 diagonal, so that's going to be 3, 6, 1, and then minus the last one here, 3, 3, 2. 3 times 3 times 2. Now let's multiply these out. 3 times 3 is 9, times 2 is 18, plus 3 times 6 is 18. 4 times 3 times 1 is 12. Now we subtract off 4 times 3 times 1, so that's a minus 12. And then minus 3 times 6 is a minus 18. And then we get a minus 3 times 3 is 9, times 2 is 18. All right, so let's just cancel these out. We don't need to do the math. Got 18 and minus 18, 18 and minus 18, 12 and minus 12. So we can see that the determinant is equal to 0 in this case. So once again, we've illustrated that this property is at least correct twice, so we know it's by a mathematical proof it's correct in all cases. I want to thank you for watching this video. Hope you got something out of it, and like, subscribe to my channel. Once again, thank you.